Substitution rule. Any rule for derivatives can be turned into a technique for finding antiderivatives simply by writing it in integral form. For example, the integral of g prime of u du dx with respect to x is equal to the integral of g prime of u du. This is the reverse of the chain rule. If you take a chain, g prime u du dx, and you take the antiderivative, what we should get is the antiderivative of g prime of u with respect to u. Let's check it out in an example. We want to find the integral of 4x times x squared plus 1 to the power of 6 dx. What we want to try and identify here is a function and its derivative, or an inside and outside function. Here we've got a composite function with x squared plus 1 as the inside function. The outside function is some function to the power of 6. We also note that the derivative of x squared plus 1 should be something like 2x. And while 4x isn't exactly 2x, they're very, very similar. So we'll let u equal x squared plus 1. That means that du dx is equal to 2x. It also means that dx is equal to du divided by 2x. If we plug those in, we get the integral of 4x times x squared plus 1 to the power of 6 dx is equal to 4x u to the power of 6 du over 2x. We get some canceling. The 4 will divide out with the 2, and the x's will cancel, leaving us with the integral of 2u to the 6 du, which is a very straightforward integral in terms of u. This integral is equal to 2u to the 7 divided by 7 plus a constant. If we sub back in what u is, we end up with 2x squared plus 1 to the power of 7 divided by 7 plus a constant. Now, of course, if we differentiate that, we should end up with 4x times x squared plus 1 to the power of 6. And if you do it, you'll find that that is in fact the case. So our substitution rule allows us to undo a chain rule derivative. We have some shortcuts. The antiderivative of ax plus b to the power of n is 1 over a times ax plus b to the power of n plus 1 divided by n plus 1. The antiderivative of ax plus b to the power of negative 1 is 1 over a times the natural log of the absolute value of ax plus b. The antiderivative of e to the ax plus b is equal to 1 over a e to the ax plus b plus a constant. The antiderivative of c to the power of ax plus b dx is equal to 1 over a natural log c times c to the ax plus b. And finally, the integral of the absolute value of ax plus b is 1 over 2a times ax plus b times the absolute value of ax plus b plus a constant. All of these are our basic rules with u equals ax plus b. Here's an example. We want to evaluate the integral of 10x cubed divided by x to the 4 plus 5 dx. Now here, it doesn't look like we have a composite function. It looks more likely that we have a ratio of functions. However, if you look at the denominator, or x to the 4 plus 5, we do have something that vaguely resembles its derivative, 4x cubed, in the numerator. Now the numerator is 10x cubed, not 4x cubed, but again, very similar. So let's let u equal x to the 4 plus 5. If we differentiate, we get du dx equals 4x cubed, or dx equals du over 4x cubed. So then the integral of 10x cubed divided by x to the 4 plus 5 is equal to 10x cubed divided by u times du over 4x cubed. The x cubeds cancel, the 10 and 4 reduce, and we end up with 5 halves times 1 over u, the integral of that du. That antiderivative is 5 halves log absolute value u plus a constant. And if we back substitute our u, we get 5 halves log x to the 4 plus 5 plus a constant. Again, if you differentiate that, you'll end up with 10x cubed divided by x to the 4 plus 5.